Hello everyone, today we're taking a look at Grasshopper, Ladybug and obviously Rhino. So in this tutorial what we're trying to achieve is basically that we have this form that we put in, and with that we also have the surroundings, and those surroundings determine the size of those panels on top of that. So if we open Grasshopper, here I already have the setup script, but we will go through it and we will discuss each and every point of it, and so it will be more clear. So what will basically happen, I will just hide this here for 1 second, those things, and also remove the poly surfaces that we have here. We basically have the output of Ladybug, which is basically this shape here, and it basically determines each of those meshes, or of the rectangulars, of the input surface that we gave it, and it basically changes it according to the variation parameters that we have here. And this will be happening also as well with the Ladybug tool, and I will get you a step-to-step tutorial of how basically can get from basically nothing at all to the reasonable thing. So just by starting, we basically need to I think maybe I need to start actually showing you where to get this from. So you basically go to foodforrhino.com, and here you just type in Ladybug, this, and then you have the Ladybug tools, and you can just download it. You have to log in most likely, and then you can download it like this version here, Ladybug 0067. This is like a tool, and again it is useful for all kind of radiation analysis. So once you have to download it, you basically need to install it as well. And once you have it installed, like the typical, you need to put it most likely in the special folders components folder. You can start scripting, start doing. So just to basically make this illustration a little bit easier, so we basically we're going to take an EPW file, which you can get a tool. I will get there in a second, and this will get us the data that we need for the areas that we want to take. So this will be the data, and this data then will be transformed with Ladybug, yeah, like this. Very nice drawing, obviously. And this data then will be a use for our form, which will be something weird, I don't know, which has a relation to its surroundings, which we also define, and then it basically will make a small definition of each single point on this mesh, or the object we put in, and will then change its size basically depending on how big it is. So it will either be like really small when there's no light, and it would be very big if there's a lot of light, or the other way around. It could be either way. So first of all, what we need to do, so we're gonna use under our Grasshopper settings, we go under Ladybug, which is LP, and then there would be the Ladybug tool. You just have to put it in here, and it will basically like come out like this. Then the next thing you need to do is you have to get your EPW file. So a very good way to get this is actually by just going to just Google EPW Ladybug, and then you go get a map of those things as well. So for example, here we have all the different zones and datas of every single country, and we can get those data in order to help us out. So maybe we can just go to, I guess, like New York, somewhere here, almost getting it. Yeah, here it is. And so they have several files, for example. They have, and then you can just like click on it, and would be able to download your file. Go to clipboard. So just go here, and then it gives us a zip folder I think I just get this on my desktop so far now on, and we open this file, look in here, and then we have, you see, a DDY file, a EPW file, and a STAT file. It actually could be that you need to install this plugin. It should be called Energy Plus. Yeah, it's called Energy Plus. It's by Microsoft as far as I know, and you can just download it, and this basically configures your laptop or your computer in order to be eligible for those files. So you might need to do that as well under download. It's for free, so it's fine. Okay, so once we have the EPW file, we're just gonna extract it really quickly on our desktop, and then we have this. So hopefully I did it correctly, but we just basically now we go and want to import this file, and we want to import it with this tool on the Ladybug EPW file. And so we're gonna set the file path, and this will be like the existing file. You got your desktop, and then we have the EPW file, and we're gonna input this basically right here. It will take us a few seconds, and then it will be getting there. And what we're gonna get to is go to the Ladybug radiation analysis, and this will have several components as well. For example, the north basically direction, the geometry, the context, the orientation study, which might be additional points, sky matrix, which we also will create, and then also like a run it and bake it command. So what we're going to do first now, we're going to create the geometry and the context of it. So I already had some of those things set up here, so we don't need to do too much more, but we maybe have those rectangles. We're just going to extrude them a little bit, move them around as well, maybe give some variation, and give this kind of almost like urbanistic environment to this scene. So we are able to this one. We're gonna create an urbanistic environment that could be set there, and we will have a more or less very organic shape that will be happening here. So it can either be some kind of loft or some true curve thing, but I think in this case we actually could maybe try something different as well. So I'm gonna just create a curve that will be set like around here a little bit. So that's our curve. So first curve, and the second curve will be somewhere around here. This, and now we're gonna we can input those two curves, and basically set the first curve here and the other curve here. And then we're gonna just make a small ruled surface command, which basically connects those two surfaces together. And we'll obviously need to maybe flip them as well in order so they're in the right direction. And now we have our curves, which are obviously changeable depending on where we want them. Okay, so those are our input curves for now. We can obviously add them and change them later, but this will be our input curves. So this is actually the first part. And now we wanna, so this would be the context of it. Then we also need to import the geometry. Sorry, there was the geometry that we're gonna use, and we're gonna also use the context of it. And this would be those things here, for example. Okay, we have them here, and they would be used as our context later. What we'll need to do if we just put those things in here for now, nothing will really happen. Because the problem is that there is no data that Ladybug can use, because we don't have the EPW file connected to it. So what we need to do is to create the selected sky matrix, and in order to do that we go to the visualize weather data and select the sky matrix like this. And we would be able to get this from here. So okay, what's the sky matrix? Yeah, we also need to create the cumulative sky matrix, which takes the EPW file. In this case, I guess we just shouldn't even need to be able to use that. And it gives the output of the sky around there. So, and the thing, what happens as well, is that we actually need to create the HOI, so it's basically hours and months of the year, and we need to create a list of that. And this was also available in Ladybug as well. So you just have HOI or under. It's a Python, well, it's a Python script in Ladybug, but you can basically use it. So it wants to have the input of all the days, all the months, and all the hours. And what we want to basically do, we want to create all the hours and all the days that are like throughout the whole year. So we want to have like an object which basically is the average of the whole year of days and hours and months to change the size of the things. So we're going to create a series that has a step of 1 because it goes only in 1 hour intervals in this case. One we will create for the days, so we have 30 days every month, right? Then one we will create for the months, which are 12 in human way, and then we are going to also create a way of the hours. So there are 24 hours on Earth, so we're going to create that hours on Earth, and same with the months, and same with the days per month. And if you put in this, for example, now, okay, actually might need to hours and days. No, that's wrong. Days. There might be a small misconfiguration because it needs to have a series starts with 0, but in this case you want to have it start with 1 in order to function properly. Yeah, so we put it on 28 days. I think it might misbehave because of the month of February, so we just keep it at 28 days for now, which is fine. It's like more than enough. And we take this HOY data in here, and now that we have this, we also need to determine the grid size, basically, which is on the ruled surface that we gave it, like this here. So it will determine the sizes of each of the elements, and as well a certain distance from the base. So we're going to just create like a very small distance from the base in this case, like here, and we're going to create, let's see how. Okay, this is 21 meters, so the grid size could be maybe around, let's say 5. We can also obviously adjust this on the go. And the next thing, we're gonna put this like sky matrix obviously in this one. Hopefully it kind of works because it seems to be kind of fraudulent at the moment. Actually don't know why it misbehaves for the moment. Let me actually check the other script, because there I certainly have it corrected. So we have to, okay, well, we always need to, there's always sometimes this command of run it, so in order for the script to also perform, because it takes a long while to be used, or it takes a lot of processing power as well. So we would have to create a Boolean toggle here as well that goes into this one. So it will basically run once you click it, and we might need to wait a little bit because it could be quite dense. And obviously also there might be the case that your fan spins up actually a little bit. Yeah, you have higher CPU power drawn, and it creates the direct diffusion. And though this component actually needs your install before the energy consumption, the energy fusion program that I was talking, Energy Plus program, this one here, in order for this to run properly, so it can determine the right thing. So now this took about 40 seconds to be calculated, and hopefully the fans will not be too loud and you can still hear everything perfectly. So this took the time to do it, and as well there is actually a for the radiation analysis, there's also a tool to use your multiple CPUs, which most of computers have nowadays, parallel, so we set this true as well. And then we are also gonna run it as well. We just use the same one here. And again, we have to wait a little bit. Well, that was pretty fast, I guess. And it gives us the radiation analysis of our thing. Now, it could be the case that if you want to change on the project on the go, you want to change those things and maybe move them around a little bit, and maybe you're a little bit unhappy with this space, and then you want to move it up a little bit. It gives you the data on the go as you as you're moving around. So, for example, if you want to have like more, let's say, more radiation in the northern part, you might need to look and change those things a little bit as well. And it basically gives us the kilowatt hours per square meter on each of those things. And what we can do as well, let me actually change behavior here a little bit. Okay, and now we don't need to also change the grid size, and this can be done, for example, here. So we can make the grid size smaller, and so the result will be more detailed, and we basically get more information out of it. The cool thing as well, if I will, for example, remove those things a little bit further from the areas, you see a better result in those things. Actually, let me just see if the surface might be the other way around, because it seems to me as if the result, okay, that makes sense. Before I was actually calculating the bottom part only, that's why it was like so, like nothing happening, but now we actually have a more accurate result of our thing. So this is actually good that we put this thing in here. And for demonstration purposes, for example, if we're taking this quadrant now down here a little bit closer, you see these surrounding areas here that are closer getting less sun. Or for example, if you're gonna make this one a little bit bigger, you see it casts a shadow in the real world, and so those things would have less shadow in total. So now that we have that, we basically have our mesh on the surface, and we can use this now to actually modify it as well. So we want basically that the areas where there are whether it is more blue, it basically will be a higher or smaller, look at this on the go, opening of the space. So we have the context mesh as an output, as well the analysis mesh, which will be colored, and then also the vectors and the central points of those maps, and then the result depending on those points. So what we're going to do is we are going to take the mesh that we have, just put it like this very nice small mesh thingy here, or we actually might want to use actually the context mesh. Oh no, we want to use the analysis mesh, obviously, so we know exactly what we have. And we have or we can use this one here as well, but I think we will stick for the analysis mesh for now. And now we are able, under mesh analysis and mesh explode, we can basically explode the mesh in each mesh in a single phase. Basically, each mesh is like in a single it's a single unit that we want to control. So we have the data now for each of the meshes that are, in this case, 162, and we're gonna have also the radiation results. So we want to basically scale if I get to my glorious drawing board here, we actually gonna actually, how do I make a new file here? Normally. So we're gonna use the radiation results, and we're gonna create a list of 1 to 0s between that, and this list will be determined to the scale. So the closer it is to 1, it will be more full, it will like cover up it all, and the closer it is to 0, it will be a smaller one, basically from the initial point. So in order to do that, we basically have the results, and if we look at the results closer a little bit, obviously this one here, we see we have a few zeros in here and there, but in all we have different sizes of the kilowatt hours that are produced. By the way, just so it's kind of more clear, if I just unlock this real quick and hide this one, you also can see a slight overview of what you want to do on the kilowatt, and this will be a result of the kilowatt hours per square meter per year. So this is the potential harvesting energy that is available, and it can be, well, for example, today's solar panels, for example, take about 20% of this data. So also if we just make a division of this by 5, so this would be 20% of the results, and if we add add this together, we basically get the total kilowatt hours for this whole building if you put solar panels on top of each other of the whole area, and that would be the result that we could get if you would fully cover it at a 20% efficiency rate. So we have that, and we have to remap those numbers now. So we just have a remap numbers. I think it's under math domain, and we have to use the bounds of the result here, and we're gonna use the construct domain command. Actually, we might not need it, but just for showing purposes, it might be useful to. So we're going to have the domain of those things, and this will be our source, and then this will be the value of it, and the target will be between 0 and 1 most likely. So I'm just gonna put this here and put this all together, nice and tight, nice. And now we have a list. If we use the target here, we have a list of zeros or 0.1s till 0.94, and this will be basically our scaling factor for each of those openings in order to create this facade, which changes depending on that. So we're going to use scale, and it wants to have a geometry, center, and the factor point. So the factor point will be this point here. The center is actually given if we can also create it, but this will be like the test points here. So there are those points here, and there will be the center of the scaling points, and then we are going to use the faces of the meshes as well. And there we have that. So I think it's gonna. So now we basically have this mesh that basically changes dependent on those things. So for example, right now we see here there's not so much light, so there is like this huge big thing, and if you're gonna remove this, it recalculates and it changes accordingly. It goes back and forth, so it will be more, so we know what to do in order to get the best outcome possible to our solution. Or if you wanna do something a little bit less, or create shadow how you want it, that you can do that. And the cool thing is now, because you have the EPW file or the files on the Ladybug side, you can basically put any EPW file in about any single country in there, and it gives you this result. So now we have the result, for example, of the geometry, and we want to put like a nice facade how we saw it in the other one on there as well. So we're going to use the, actually I want to put this one here for now, a bit closer, like that. We're going to use under mesh and face boundaries, we are going to use the mesh boundaries, the command, in order to get the outlines of the mesh. And we are also going to use this as well for the meshes that we have. We actually will have to use it for the meshes that we have at the beginning. So right now we have this outlines mesh and those meshes as well. Actually, just let me move one a little bit down here because it looks kind of, I think it was like totally covered in it. And now we're gonna basically use just a simple rule surface, just how we made it in the beginning. So we go full circle to connect those two, and now we have a nice grid like that. And again, it's obviously fully customizable and changeable. It might take a while to always change those things. And obviously we can just pick this geometry up here, gonna go into view and preview. So then now we have our nice grid that perfectly fits on the sun area here. And if we also gonna, then we can obviously use this geometry, and we will be able to maybe position ourselves like here, there maybe, and then we can use this geometry perfectly for rendering V-Ray, for example. I will not use any settings, I'll just see how it will look playing out of this thing. And as the renderer basically continues to see, well, the area in here. Yeah, you can tweak the rendering obviously as well. But yeah, so that's basically the way how you can tweak your design according to the needs that you have, and you can really change it and adapt to it. And it gives us obviously a lot of more possibilities, because you can always continuously change in it. You have the data, you can show the data as well with the command like this one here as well, the Ladybug tool. And actually, if we're gonna bake it quickly, yeah, we have the tools as well of data here, which always makes a really nice way of persuading your client or your teachers or whoever you want to please with this grandiose discovery. So thank you very much, and I hope this can help you as well to understand it and to use Ladybug as a tool to alleviate your designs to make sense, or to have a solid reasoning that no one can take away from you. So thank you very much, and goodbye.